Hello, guys. Welcome to the stream. Welcome to the stream. Nice Monday for everyone. We finally got the headphones instead of the the wired earbuds. The hair is not liking this as much as I thought it would be, but it's good enough. Good enough. How's what is that in my? I can't tell what this. Oh, it's my door. Bro, I was so confused on what that is. I was like trying to figure it out. Okay, that makes more sense. So guys, I think we're gonna do some pretty exciting stuff and we're gonna get back into doing some vector math, you know? Obviously just the most exciting stuff ever. Obviously. Last time I don't even know that we got far. But we did some stuff. And what are we? Oh, the issue we're facing is let's see. It was kind of going like all or nothing. And so it was kind of, there was a lot of times where it was like, oh yeah, there's an object here, so go left, and then there's no object left, so it goes left, and then it checks the same way again, and it just like it keeps going back and forth, like towards the target, away from the target, towards the target, away from the target, towards the target, away from the target, and so it gets stuck. So, oh, also, the Discord is up. Let me let me put it in the channel description. Channel. My channel. Hold on. Let's go here. Links. Okay. And let me grab the Discord URL. Actually, it's right here. All right, I just want to put this in the chat so that way anyone who comes in the stream can join, or put it in the put up my channel info so that way people can see it. Cool. All right, awesome. All right, the Discord is in the stream information, or the my channel information. So definitely go ahead and join the Discord, bro. Pretty sick. Let's see. let's get back into it. Let's get back into it. So, oh yeah, let's see if we're splitting. So the last thing we did was we wrote this function to pretty much just make two random rays, and then make another vector, split them to make sure our vector bisect equation / method works. Bro, this is not. The hair like really does not like these headphones. It is what it is. It is what it is, but also it's bugging me. All right. That's, I think, just gonna have to do. Okay. Is what it is. It'll be fine. Okay, let's see how well this is working. Okay, that looks like it split it. That looks like it's splitting it. That looks like it's splitting it. Oh, and then we were logging if the difference is greater than like 0.01 or something. Yeah. All right, cool. That's right. Okay. So, and even if we increase the speed to like, nah, we're not gonna do that. Okay. So now that we know we can bisect the vector, that gives us a starting point. This was the old way we did it. Instead, so if there is an obstacle, yeah, what you want to do is determine the angle at which the enemy should move. So let's just do a quick example. Let's just go ahead and do that here. So we have an obstacle, and this is our enemy. This is our goal. So obviously it wants to move this way. Can't do that. So instead it's going to check it this way. And it's going to go here. It's going to check this way. No. We don't want that. We don't want that. Okay. We're going to put our enemy here and our target here. So we want to go this way, right? But there's an object here. So we start to move not this way, but we realize that direction's open, so we're going to move, split it in between the two, right? Now we're here. Same thing, right? But this time we're going to move a little bit closer. So now we're here. Same thing. And now we're gonna move maybe like only 30 degrees instead of 45. Now we're here. And now, like as this is going from, actually, hold on. I think I lied. Because it would be here. That's a terrible circle. It would be here, and that would be there. Or, I mean, it's kind of close, right? So it'd be that way, but then 90 degrees is this way, approximately. Let's split those two. Go here. 90 degrees of this is, so it actually start moving. Well, no, because at this point it's not getting any closer to. It's not getting any closer, so it's going to do that. But now if we change where the target is, have the target be up here instead, now all of a sudden we're going, okay, I want to go that way. I see this object here. So let's check left. There's no object there. And this is a funky one where, like, yeah, obviously it's easier to go up here. But to check that, I think is inconsequential. If it goes around this way, I don't think that's a big deal. Especially since for the most part there's going to be a lot of them. And even if there's not a lot of them, like if the player thinks it's going to go this way and then it starts going this way, the player will go this way because it thinks this is going this way. So this is its initial thought is what it's going to do. So the player goes this way, but instead it goes this way and the player's going this way. So they meet here. Not really, but you know, I don't think unpredictability, and I don't think it always has to be optimal. I don't think unpredictability is bad. I don't think being optimal is super duper important. But anyways, it'll go this way, right? And then you're like, okay, well, now we're talking this way. And now I'm like, okay, well, now talking that way. Not too much different. I mean, there and like here, right? Like that's about right. So, okay, a little more than 90 degrees. And now we're talking up here. Okay, so now we're talking up here. And this way isn't good anymore either. So now we're talking this way. So I'm going to bisect these two. And it's going to end up going this way. So now you're talking, okay, now it's a red alert, right? Like we have an object right here. This way is not safe. Checks that way, nope. This way is safe. So you're going to want to go like, it's going to go like here. Or maybe even like here. So now we're talking like here. It's kind of the same thing. And let's say this way is free. It'll move here. And that's not completely optimal, right? Or that's not completely that's not entirely how it's going to go because there's much more granular checks. But it's close. So the closer to the object, the closer to the free angle. And the further the object, the closer to halfway between the target vector and free vector, or like open vector, I guess we could call it. Okay. So then what we do is we determine this by doing, so we have like the sight distance, right? So the sight distance minus the object distance. We'll say closer to 0 is further away. Because the closer the object distance is from the sight distance, the closer it's going to be to 0. So the higher this is, so if this is like a 0, so the range is the That's one thing to note though, right? Is that how do you figure out what how do you figure out what the like the range is? Oh, I guess you would just do like the range is just the bisect vector to the open vector, right? You just make sure both were normalized. Like if this is -2, 3, and this is 6, 2. So if you do all you would do is take you would do absolute value of x1 plus absolute value of x2. Same thing with the y's. Which gives you, say, x, we'll call it x0 and y0, or x naught and y naught. Then, so this is the total. So like, that's x naught. Oh wait, hold on. That doesn't work, does it? No, I lied. That's not accurate. So what you actually want to do is x1 minus x2. Then absolute value of that. Same thing with y's. Because then this is going to get you -2 minus 6 is going to be -8. Take the absolute value of that, and then it's just 8. And this is going to be -2 minus, or -3. No, sorry. 3 minus 2 equals 1. As the value of 1 is just 1. And you can flip it and do 6 minus -2 is just 8. And 2 minus 3 is -1, which is then 1, because you absolute value it. So once you're able to get the distance between the values, which is 8 and 1, from there, you determine your ratio, right? Oh, but how do you know whether to add or subtract? Because, so you're going to have a ratio from, your ratio would be, it'd be object distance to sight distance, or the C distance. So as the object is further, really good writing there. That's terrible. That actually is, as the object is further, it's going to get, it's going to approach 1. As the object is closer, it's going to approach 0. Because this is always going to be, like, this is whatever. So the object, or let's say you can always see 1 away, right? So if the seeing distance is 1, then this varies from 0 to 1. Can't be further than 1 away because you can't see more than 1. So as soon as it's on your horizon, as soon as you see it, it's 1 away. And so then you have 1 unit away. So then you have, your ratio is 1. If ratio is 1, so 1 equals the bisect vector. And 0 should equal the open vector. Okay, so now we're coming to some sort of conclusion. The only thing is, so let's say your ratio is, we'll say in our example, our ratio is, let's see, r equals 1/2. So you say, okay, 8 divided by 2 equals 4, and 1 divided by 2 equals a half. So in this case, what happens? In this case, let me there we go. And let's for a second just say this is our open vector and this is our bisect. How do we determine wait, I'm confusing myself. I'm confusing myself. Oh my gosh. My brain is being boiled by these maths. Like, this isn't even complicated math. I'm really struggling to like get my head around all the different parts at the same time. I swear, like, I understand all the parts, like all the pieces individually. Bro. That's good, that's good. I swear I understand all the pieces individually, but like when I try and put them all together, my brain just like throws up everywhere. So if this is the bisect vector, that means we're going what, like this way? Almost. I mean, let's say it's more like this, yeah. So that's the target. That's just completely incorrect, but okay. Okay, you know what? Let's just select all, delete. Okay. We're starting fresh. We have our enemy. We have our target. That's the target vector. It's a wall. This is our open vector. And this is our bisect. Let's see our ratio, which equals object over seeing distance equals object over 2. So the object is 1. So it's 1 over 2. Okay. So this means you want to be halfway between these two. No? Yes? Yes. Ratio is half. You want to be halfway between these two. I'm starting to understand now. Which means, let's draw this on a bigger scale now. Let's do this and this. So this is going to be, I don't know what it's going to be, but let's say like -2. Oh wait, no, it'd be, yeah, -2, -3. And then this is like 3, 4. I don't want it to be the same. I want to be a little bit different. I know it's not very accurate of their picture, but halfway between them would be -2 and 3 would be 0.5. -3 and 4 is 7. It'd be 0.5, 0.5. Does that even make any sense? No, because that's -4. That's why. All right, hold on. So yeah, let's do -2, -3. So it's called the origin. -2, -1, 2, -1, 2, 3. And this is going to be 3, 4. 1, 2, 3. 1, 2, and this is 3, so it's called there. Okay. So now halfway between this is oh, that's still -4. Oh my gosh. I don't like that you can't see the eraser. Okay. That's 3, -4. Thank goodness. Okay, so this is halfway between them is no. It's 0.5. -3.5. And how did I get that? Let's see. So we took -2 plus 3 equals 1. So I gotta say, I actually did what I did. Didn't I do? I think it's actually 2 minus 3 is what I did. Like, I think you could do it as 2 minus 3, which means you do -3 minus -4. And then do you absolute value them? Because that's -1. And that's 1. No, -2 minus 3 equals -5. Hold on. There we go. There we go. Okay, so this is the this is distance between them, right? So you divide both of them by 2, and you get -2.5, and then you get 0.5. So I subtracted. So if you do -2 minus a -2.5, you get 0.5. And then if you do -3 minus 0.5, you get -3.5. What if you do it the other way? You get 3 minus 2.5. Okay, see, that doesn't work. That doesn't work because it's 3 minus a -2.5 and -4 minus 0.5 equals 5.5 and -4.5. And obviously 0.5 -3.5 is about right here. Seems split pretty much evenly. And this is 5.5. 4.5 is literally that way. Okay, so not great, right? Right. Oh wait, no, it's not. 5.5 negative 4.5. That's like there. It's just random. But then how do you know which one to... How do you know which one to... What if I just say like how to... Or wait, isn't there still... Vector 2 lerp. Okay, so this, I think that's what I need to do. I've sat here for the past 40 minutes trying to figure this out, and that's what I needed to do. All right, so linearly interpolates between vectors A and B by T, which means wait, what's T? T is the parameter T is clamped to range 0, 1. Well, that's your ratio. Okay, so what are my steps now? So get open vector. Bisect with target vector. Get ratio of object distance to site distance used to determine movement direction. All right, let's do this. To bisect a vector, we take the other two vectors and normalize them, add them together, and then normalize the result. Okay. So we have check ahead. First, we're going to check the direction. So, oh, yep, that's right. Okay. So if you find an obstacle, if we find an obstacle in the path, right? Let's check movement. Then we're going to check every direction. And then whatever direction doesn't have a object, that's our free space. Now from here is where we start doing stuff. What I want to do is bisect, so we're going to say vector to bisect is going to equal free space normalized plus what else? The we'll say the movement currently normalized. I don't want to do that. Normalize this. Movement is a vector 3. Let's say vector 2. Target direction. Oh, let's do target direction equals movement. Let's do that. There we go. Yep, so now 2 becomes bisect the free space vector and the target vector. Okay. All right, so after doing that, bisecting free space and target direction, then I want to find ratio of target distance, or not target distance, of obstacle distance to site distance, which is just going to be, we'll do float, ratio equals there's not a, distance to obstacle. Divided by circle cast distance. Also, let me just make sure this is being used somewhere. Yep. Okay, cool. Then, after this, I want to determine calculate the movement vector as the ratio from the bisect vector to the free space vector. And all we got to do there is do movement equals vector 2 dot lerp between the bisect and the free space at ratio. Okay. Just go ahead and comment that out. Normalize the movement. Set the movement as the velocity. All right, let's see if this completely fails. I feel like it probably is. What fun would it be if it worked right away? That would be so boring, anticlimactic, you know? Also, I don't know about these guys. They're kind of pressing on my ears. Like, quite a bit. And I feel like I have them like the correct. Is that 5? No, it's 4. I've been messing around with like how loose they are, but I feel like if I make them any looser, they're just gonna fall off my face. That actually might be nicer. That might be nicer. Okay, let's see what he does. Wow, that was impressive. Why is it staggering? Let me find the. No, guys, it's actually not any better. That was no better whatsoever. Let me find debug dot drawline. Is that the only one? Okay, so enemy movement is the right one. Okay, first of all, let's just stop calling this one. Just get rid of that. Let's get rid of this draw lines function, honestly, too. We don't really need this. Okay. Now. It's this one, right? Because if we go here, and we play it, it's not going to draw anything. So I'm curious if I can tell. Let's do this. Let's get rid of him. Let's rounds. Turn this back on. And let's just mess with this just a little bit. Let's do spawn limit 30 spawn rate every half second. Okay. I want to see what this looks like. Okay, so a lot are still doing this dance. Interesting, interesting. All right, well, let's do, I guess let's do this. Maybe. Let's try with just one first. I'm also just going to delete all of this. Okay. Yeah, guys, I really don't know how this is going. Well, I know how it's going, and it's definitely not going well. Just go ahead and enable this guy. So for the most part, it works good. But still, if there's... There's an object here, and it says, okay, my ratio is 1. So I'm going to go at a 45-degree angle, right? No, I feel like it... Is it not doing what I wanted to do? No, it's not. Even though movement is... All right, let's go back and stop this. I want to debug the... So let's do the target vector. And then this can be the, we'll call this the open vector, the bisect vector. And the ratio. Free space, bisect, ratio. So why did it just automatically go all the way over there, right? So we're saying the okay, let's kind of graph this out. Ready? Select all, delete. Okay. So it's our quadrant. Oh, here's the oh. Can we do this then? Okay, this works. This works. We can work with this. All right, so we have oh, whoops. Okay, well, either way, our open factor is like -2 -9, so that's like here, right? Let's do this with this. Decrease the size and do it in like green or something. Yeah. Then start target. No, sorry, that's our open vector. Then we'll do our bisect vector is pretty much -9. -5. Okay. Oh, okay. There's a lot of things that we're not printing here. Okay. First thing is that this should not be target. It should be target direction. And I need the movement. Oh. Okay, there we go. Okay. Now, let's try this again. See if we get anything better. Okay. Okay, so that's it right there. Let's grab this. And let's just Control Z, last couple things we did. All right, so we have the target vector. -10, essentially. 2. Okay. Let's target. Then we have the open vector. 2. Oh, that's another one. 2. Open vector is -2, 10. Pretty much the same as the last one. Okay. And these are not super accurate, but that's okay. Then we'll do the bisect is -8, almost -9. -5. Okay, so that's about right. That's about right. The bisect looks good. Now the movement, the ratio is 1. Sir, how is the ratio 1.5? How is that even possible? Am I tripping? Are you tripping? What the heck is going on? All right, let's figure out where the distance to the obstacle is. Okay, so box cast all. We have the origin is the transform position. That makes sense. The size of the box is 5 by 5. Okay, sure. The angle is just rotation C. Okay, sure. The float angle is direction. Float distance is this one right here. Circle cast distance. So this box only goes circle cast distance away. That's how far it goes. Now, distance to the obstacle is factor 3 dot distance from this position to the object that was found, because object is hit transform game object. So distance from this object to the object that was found by this raycast. Am I misunderstanding something? I feel like distance to obstacle can't possibly be larger. So what we're going to do is I'm going to create a crazy log right here. We're going to do debug log. Obstacle distance divided by cast distance. I'm sure this sounds just dist, just for, you know, keeping it short and sweet. So then, you know, this makes sense. We're going to do obviously distance to obstacle divided by circle cast distance. Let me go make sure that I'm not doing something like, okay, nope, the ratio is this to this, and we are printing the ratio. Okay, having the ratio at 1.5 is definitely the problem. That is definitely causing issues. I don't know why it's at 1.5. I don't really know. I don't really understand. Well, it's 1.5, so that means it's 1 because it's capped. So that's why it's going completely when it should just be going partially. Okay, so this makes sense. This makes sense. We just have to figure out why it's 1.5. Okay. Then we're also going to add a space. No, in parentheses. Distance to obstacle plus circle cast distance. There we go. Save that. All right, come at me now. Come at me now. I'm gonna cook. Clear all these silly logs. All right. We about to print some nasty logs. We about to solve this problem right away. Right away. Right away. Right away. Put this back here. Go and start. Boom. Okay. These logs right here. So we don't need it to be that big. We actually don't need it to be that big. Can we like? No, we can't. All right. Okay. It can't. How? Bro, how did this get 36 divided by 20? Do I not know how CircleCast works? Bro, let me look at. All right, I gotta look at the documentation for this now. Wow, good typing, good typing. Is it even a circle cast, or am I doing a box cast? It's a box cast all. Okay, let's do box cast all. Physics 2D box cast all. Okay, this is what I'm doing. So it casts a box against colliders in the scene, returning all colliders in contact with it. Conceptually, like dragging a box through the scene in a particular direction. Any object making contact is detected, reported. Okay. Oh. I figured it. Guys. Came to a crazy revelation just now. So we're doing our thing over here, right? Little bro, my circles are so bad here. Okay. So we're gonna say let's say this is the case. This is our target, right? We are casting this direction, and our cast only goes, let's say that's our cast distance. But when I'm getting the distance, I'm doing the distance from the center of this object to the center of this object. So it's going, woo. So I want to do the distance from here to here. Which means, in reality, I do not want to do a distance from the position to the object position. I want to do the distance from my position to the collision position. And raycast hit to D point. The world space position where the physics query shape intersected with the detected collider 2D. So instead I want to do hit dot point. And let's go ahead and put a little, just so that way it's easier to see in the logs. Guys, that was such a big brain play. I just should have done it sooner. But I figured it out. I feel like once I kind of isolated the problem, realized that the ratio was wrong, I was pretty quick to understand. That was why. I don't even know how I realized that. I really don't. Like, how did I even think about that? All right, ready. Look for him. Okay. Now for the real test. Just get rid of all those. Oh, guys, we're jamming now. We're jamming. Also, oh yeah, now it's just in the correct ratio, so it should be good. All right, let's turn rounds back on. And let's turn default enemy off. All right, let's see. Not a lot of, okay, a little bit of staggering there. The real test is be, are they gonna like die over here? Also, that's interesting. Okay, so this is something that I did consider when I first saw this, until I saw that there was like a 36 distance compared to a 20 sight distance. But I did think about the fact that you're casting a cube, right? So if you're casting a cube, you know, this far, does the cube stop when it gets, the right edge gets there, the far edge? I doubt it. I'm pretty sure it would stop either here or here. But this is a lot more like this. Essentially, just if it stops here or wait, no. Yeah, if it stops here or here, that's a terrible cube. That's not even a cube at all. But if it stops in the middle or on the right side, that just means you either have 2.5 units or 5 units of extra, to where if you are 5 away, it's going to treat it as if you're right there, which is like that. That's fine. That's fine. But nothing's over about 1.1. Highest one I'm seeing is 1.5. That's 23. 1.3. So we're doing fine. We're doing fine. If we set it to 25, we'd be golden. But I don't think it's that big of a deal. Okay. So now let's see. Okay, this guy right here. This little dude. What's his, let's pay attention to his velocity. So it's -2, 39 to -39. Interesting. I wonder if it sees. I'm curious. I can't tell you that this is the reason, but I have a hunch as to what it might be. If you have an obstacle here and your guy's here, but let's say the square you're casting is this big, right? So now you say, okay. Wait, how big is a 5x5 square? Can I throw something in here? So it's unlikely that it is, right? It's unlikely, but it could be. Because theoretically, if you then if you cast a block this way, I mean, you would go left first, right? Left first. And you'd say, all right, cool. That's blocked. This is blocked. Oh, we can go this way. splitting the distance. But you're so close to it. You should just be going this way, shouldn't you? Like, what's... Like, you're telling me this guy's going... -2, 39 or 39 or whatever. That's... Like, why would he be going right? Okay, I understand why he would be going right. Okay? I understand why he would be going right. But then why now? Even if you say, okay, this... Maybe the square hits here, right? Why wouldn't this be open? Why wouldn't you go here? I just don't quite... It turns right back around. That's going -239. I don't understand that. That doesn't make sense in my mind. And I don't really know how to get logs for that. Because, like, I can't really make one do that. I really can't. Like, it just doesn't... So he's just going to be there forever. Not forever. Okay, so there's still guys doing this little side quest dance on this. Alright, is there any issue that's solved with me doing it this? And just bringing these closer together. I can also take these logs and move them a little bit further out. I don't think that's a problem with the map itself. No, it shouldn't be. All right, let's see if this solves any of those problems. If maybe our paths are just too... The paths, I think definitely moving them away will help. But to what extent, I guess, is what I'm trying to get at. No, I still don't like that. That is helping. These guys are still... Look at these ones, though. These guys are bugging out. And why is there such a tight-knit circle right here? Let's go to point movement. Let's say do this. Whoa. Okay. That should stop them from getting the same point again, which I felt like wasn't going to happen that much, but I guess with the sample size of 4, it's pretty common. It's a 1 in 25 chance, so with 40 things going around, it's bound to happen a lot. Decent amount at least. Don't like that. Ha ha ha. Man, I don't know. There's a lot of things, like little tiny things that I feel like are really causing this to mess up. It's definitely not helping that. Why are they spinning in circles, man? Why are they spinning in circles? Why? Listen to too much Post Malone, man. I don't really want to do that though. Yeah, you want to do this while current position equals last point. Yep, that might help. That might help. That's gotta solve it. That's gotta solve it. That specific issue. It's gotta solve it, bro. It's gotta. I'm telling you. We can make the margin bigger also. We could try that. Okay, goes away. No. Okay, we're gonna try 2 different things this time. First of all, I'm gonna set current point to a random number instead of setting current point equal to 0. Current position is gonna be set to a random number upon starting. Okay. That's going to help. And then I'm also going to increase the margin. I don't know what it is right now, but I feel like it's probably kind of small for the amount of enemies that we have on the screen. Enemy movement. Where's the margin? It's different for the different ones. Yeah, 0.1 is too small. Set it to like 3 or something. So now all of them shouldn't go to 1 at the start. Let's see. Okay, this one goes over here. These guys are stuck. How do they accomplish such a feat? All right, guys. I think I'm going to end the stream a little early today. Maybe do some research on Boyd movement. Try and figure out what's going on here. But make sure you join the Discord. Join the Discord. I'll probably put an announcement out later this week or next week that soon I'm going to be doing a game day where I'll be playing a video game. I'm not sure what it's going to be yet. Honestly, it might just be Minecraft. We're going to see. We're going to see. But anyways, guys, thanks for jumping on. Thanks for watching the stream. Make sure you go check out the YouTube if you want to check out some of the VODs that you missed. And hope you guys have a good rest of your day. See ya.